Okay, are they acid-base reactions? If they are, that means we'll be able to identify acids and conjugate bases, bases and conjugate acids. So we need to see proton transfer. We need to see one of our reactants gaining a proton, one of our reactants losing a proton. Now in question A, that's easy. We've got hydroxide, OH minus. If that gains a proton, what does it turn into? Water. We see ammonium losing a proton to turn into ammonia. Difference is a H plus, just the same as the difference is a H plus here. So, yes. Conjugate acid-base pair, OH. Conjugate base is hydroxide. Sorry, the base is conjugate oxide, the conjugate acid is water. The acid is ammonium because it loses proton to turn into its conjugate base, which is ammonia. Second, is this an acid-base reaction? So does HCl lose a proton? Well, it sort of kind of does, in that HCl ends up as chloride ions in aqueous magnesium chloride, but magnesium doesn't do anything to do with protons. It doesn't gain a proton. In fact, it loses electrons. So since magnesium doesn't act as an acid or a base, this is not an acid-base reaction. We can't identify conjugate pairs in this question. Compared to the next question, where it's easy to. What do we see? We see phosphoric acid, H3PO4, loses a H, loses a plus. So it ends up with two H's here, and the neutral charge goes down to -1. Water gains a H plus, gains a H to turn into H3O, gains a plus to go from neutral to +1. So for that reason, we've got the two conjugate partners. Conjugate acid because it's losing a proton. Sorry, acid because it's losing a proton, turning into its conjugate base. And in this case, water is acting as a base because it's gaining a proton to turn into its conjugate acid.